Okay, so section 10.7 and the extension. You're learning the extension, you're doing homework on the extension, except you're not tested on the extension and it is not on your final, but I would like you to know it. Okay, so this is the last section you need for your final. It's 10.7. So just putting all of the quadratic equations, right, in two variables now together. So your conic sections. You're solving quadratic systems, right? So when we were looking at linear systems, it was taking two lines and figuring out where they intersected, okay? Same thing for solving a quadratic system. You're taking two conic sections and deciding where they're intersecting, okay? So if you we did it using substitution or linear combination. You're gonna do the same thing for these. Okay, so looking at this first set of systems, you have two, okay? So, actually that's solving. Just thinking about conic sections in general, we'll solve it together. Or I'll solve it for you, I guess. Right, if you think about what conic sections are, right? So like a circle and a parabola, they could potentially never intersect. Maybe they'll intersect in two places, one place, four places, 3 places. Okay, so we're looking for, that's what these are showing you, are possible places that they could intersect, right? So two lines can either intersect in one place, be the same line, or not intersect at all. When you have conic sections, you have anywhere from 0 to 4 potential points of intersection. Okay, so solving a quadratic system, done the same way that you solve linear systems. Okay, you're looking for their points of intersection, so you need to find x and y. So we're going to use substitution or linear combination. Generally, with conic sections, you have both x and y being squared. So it will be easier typically to use linear combination to cancel out a variable. But you can use linear combination, okay? Or substitution, I mean. So if I have x squared plus y squared equals 5, and y equals negative x plus 3. Okay, these are my two equations. If I think about what they are, this is a circle and a line. So think about where a circle and a line could intersect. They could not intersect. They could intersect in one place, or they could intersect in two places. Okay? So we have to figure out where those points are. So given that y is already solved for, I'm going to solve this using substitution. So I'm going to take this, plug it in for y up here. So I'm going to get x squared plus negative x plus 3 squared. Okay, then I'm going to solve for x. So I get x squared plus negative x plus 3 squared is x squared minus 6x plus 9. So x squared plus x squared is 2x squared minus 6x plus 9 equals 5. Okay, this is just a quadratic, so I'm going to put it in quadratic form. So I subtract 5 from both sides, and I get 2x squared minus 6x plus 4 equals 0. Then I have to factor that, okay, or try. First thing I notice is I can divide everything by 2. And I get x squared minus 3x plus 2 equals 0. Can you factor this? Factors of 2 that add to negative 3, x minus 1, x minus 2 equals 0. So I get x equals 1 and x equals 2. Use the zero product property. I'm not done though, because I'm looking for points. So this is one x value, a second x value. Okay, so I need to find the corresponding y. So when x is 1, y equals negative 1 plus 3, which is 2. So my first point of intersection is at 1, 2. Then when x is 2, I get y equals negative 2 plus 3, which is 1. So 2, 1 is my second point of intersection. So solving using substitution was easy because y was already by itself. Okay? When that's not the case, then you can use linear combination. Okay, you can use substitution, but if one of them is easy to solve for. Okay, so my next one says x squared plus y squared minus 64 equals 0, and 2x squared plus y minus 8 equals 0. Looking at these, y is easy to solve for. X squared, y squared, not so easy because you have to take square roots. So I'm going to solve for y in the second equation. So that means y equals negative 2x squared plus 8. Then I'm going to substitute that in to our first. So I get x squared plus y squared minus 64 equals 0. So, but y was negative 2x squared plus 8. Okay? Then simplify this. So I get x squared plus 4x to the 4th minus 32x squared plus 64 minus 64 equals 0. Remember, to square something, it means to multiply it by itself. So I'd get negative 2x squared plus 8 times negative 2x squared plus 8. Simplifying this, the 64's cancel. Then I get 4x to the 4th minus 31x squared equals 0. And factor. So I'm going to take out an x squared, and I get 4x squared minus 31 equals 0. So x squared equals 0, and 4x squared minus 31 equals 0. Then solving for x, I get x equals 0, or x equals plus or minus the square root of 31 over 2. Okay? Then for each x, you need to find y. So if x is 0, then y equals negative 2 times 0 squared plus 8. So y equals 8. Okay, so I get 0, 8 as one solution. Then do plus here or minus. So we get y equals negative 2 times 31 over 2 squared plus 8, and negative 2 times negative square root of 31 over 2 squared plus 8. So I get negative 7.5 for both of them. So my points of intersection would be 0, 8, plus or minus the square root of 31 over 2, negative 7.5. I think in your notes I put them both as decimals. That's okay. Just writing it as a simplified radical. So solve for x or y, then go back, and for each x or y that you found, you have to plug it in and get the corresponding variable term that you didn't already have. Okay? So substitution when you have either a x or y to the first power. Otherwise, you're going to want to use linear combination. Okay. So last one, we have negative x squared plus y squared minus 36 equals 0, and x squared plus y squared minus 32y plus 156 equals 0. Remember, with linear combination, the key is to cancel out one of your variables. X is going to be easier to cancel out because we have just an x squared term. Y, we have y squared and y over here. So look at the coefficients, make sure they're opposites. I have a negative x squared and a positive x squared. So I'm just going to add my two equations together. The x's cancel, then I get 2y squared minus 32y plus 120 equals 0. Now I can solve for y. So again, I'm going to divide everything by 2, or factor out a 2. Okay, so I get y squared minus 16y plus 60 equals 0. Then factors of 60, that add up to negative 16. So y minus 6 times y minus 10. Then use a zero product property. So I get y equals 6 and y equals 10. Then you have to find the corresponding x values, okay? So when y equals 6, we get negative x squared plus 36 minus 36 equals 0. So I get x equals 0. So the first point of intersection is 0, 6. And then when y is 10, I get negative x squared plus 100, because that's y squared, minus 36 equals 0. So negative x squared equals negative 64. So x squared equals 64. And then x equals plus or minus 8. So that gives us two other points. So we get 8, 10, and negative 8, 10. So 3 points of intersection on that one. Okay, so linear combination, cancel out a variable. Substitution, solve for one, find the other. Okay, and that's solving systems of quadratic polynomials. Okay, so we're looking at where those conic sections now intersect.